Hello friends, today's question. In Searle's experiment, which is used to find Young's modulus of elasticity, the diameter of experimental wire is D, given as 0.05 centimeter, measured by the scale of least count 0.001 centimeter, and length L 110 centimeter, measured by a scale of least count 0.1 centimeter. A weight of 50 Newton causes an extension of L, that is small l, which is equal to 0.125 centimeter, measured by a micrometer of least count 0.001 centimeter. Find the maximum possible error in the values of Young's modulus. Screw gauge and meter scale are free from error. So this question is quite straightforward. That is based on, you can say, how we find out the maximum possible error. So in Young's modulus, so if y is the Young's modulus of elasticity and delta y is the maximum possible error, so we have to find out the maximum possible error, that is delta y. And in order to find out delta y, we should be knowing the value of y. Okay. So we start from there only. We start by finding the Young's modulus first, that is y. So we say Young's modulus y, it is given as stress oblique strain. Stress is our force oblique area, so we substitute it here. Y is equal to force oblique area, and strain is change in length divided by original length. So change in length is extension, which is given as small l, and the original length is capital L. So we substitute here, we get L upon capital L, and this can be written as F multiplied by capital L divided by area multiplied by small l. And area in the question, it is given in the form the diameter, so we just reformulate it. We get this as F multiplied by L divided by small l pi d square divided by 4. Now we substitute the values. We get y is equal to 50 is the applied force. Original length is given as 110 centimeter. So we can write this as 1.1 meters, and 4. And similarly, length is 1.25 10 is to the power minus 3, and we have pi, and we have a diameter. Diameter is given as 0.05 centimeter, so we can write this as 5 into 10 is to the power minus 4 and whole square. So we are going to get this value of y will be approximately equal to 2.24 10 is to the power 11 Newton meter square. Now we are going to find out the maximum possible error, or we can say uncertainty in the value of Young's modulus. Uncertainty, so we can write it as delta y upon y will be equal to delta f upon f plus so this becomes 2 delta d upon d, and plus we have delta l upon l, and our force is, you can say, given as constant, which is 50. So f is given as 50 Newton, so obviously value of delta f will be equal to 0, so this term goes away. So we are left with only delta y upon y will be equal to, I missed one, I think, capital L I missed, so this will be plus capital L divided by small l. Therefore we can write this as capital L upon small l plus extension divided by original plus twice delta diameter divided by diameter. Now we substitute the values. we get this as delta L, that is you can say with the least count that is given in capital is 0.1 centimeter. So this becomes 0.1, original is 110, plus extension is given as 0.0125. So we have 0.125 and least count is given as 0.001. And we have given a diameter that is twice. Diameter is given as 0.05 and measured with the least count of 0.001. So this gives us, it will be equal to 0.0489. So this is nothing but delta y upon y. So from here we can say our delta y will be equal to y multiplied by 0.0489. We just calculated our y. So we substitute it here, we get delta y will be equal to y is 2.24 into 10 to the power 11 multiplied by 0.0489. And this gives us delta y will be approximately equal to 1.09 into 10 to the power 10 Newton meter square. Okay. So this is the maximum possible error in the value of Young's modulus. So you can write it here. This is maximum possible error. So this question was also quite simple, directly based on the only the formula is different, and we can find out what is the maximum possible error, which usually is quite easy to find out. So this completes the question. Thank you.